Hello, my name is Patricia Ponsell, and this is my Physics 2212 Lab 4. Using the loop rule and the node rule, we will predict behavior for parallel and series circuits. We'll use multimeters to measure the values of conventional current and potential differences. We'll observe behavior of resistors and capacitors. Two key principles are the node rule and the loop rule. The node rule involves conservation of current. It states that the total current going into the node is equal to the total current coming out of the node. The loop rule is the conservation of energy. It states that the potential difference around any closed loop is equal to 0. Before we start the lab, we will make two predictions. We will first say that the measured I1 and I2 values will both be equal to 0.02 amps. We will also say that the total potential difference should be 0. We made some key observations after doing the lab. We saw that prediction 1 was correct. We predicted that the current would be 0.02 amps, and we found that the ammeter read the same forwards and backwards, so if you were to take the ammeter and flip it upside down, it would read the same. We also found that when you add a voltmeter, the ammeter would read 0 and the voltmeter would read 3. 3 volts is the EMF, and the current does not flow through a voltometer due to extreme resistance. We also saw that prediction 2 was correct. The voltmeter is in parallel, so it can't alter the current. The difference across the 100 meter ohm resistor is 0, and when we add an ammeter in parallel, it increases the value of the current because it adds a path of least resistance. The lab document asks us to describe the resistance of the resistor and the other components in the circuit. The resistance of the resistor is their ohmage, and the resistance of wires and the ammeter are both 0. The next part of the lab, we made observations about an RC circuit. We saw that the light dims when it's connected to a capacitor in the battery and in series. When the battery is removed, the capacitor discharges to light battery, and the current decreases while charging and discharging. The capacitor takes about 8 seconds to fully charge and discharge with the 10 ohm bulb, and it takes 16 seconds to fully charge and discharge with the 20 ohm bulb. After we made observations and collected our data, we created a voltage versus time graph. We saw that the voltage versus time raw data produced a downward sloping exponential curve. After taking the log of this graph, we see that there is a linear negative correlation. We will now make two considerations. What if you were doing this lab in real life and used an actual ammeter instead of an ideal simulated ammeter? We would not get the same results because resistance exists in the real world. There's no such thing as no resistance or a perfect circuit, so we would see deviation in this ideal values that we get. Secondly, what if we were doing this lab in real life and used a real battery to charge a real capacitor with no resistor in the circuit? We would see that it would take longer to charge the capacitor because the inefficiency in the wires and the resistance in the circuit.